Except, well, a couple things. And again, hopefully this is a refresher. When we see this little square right here, what that is telling us is these two lines, so this line here and this line here, form a right angle. And a right angle always has what degree measure? You know that? Yeah, 90 degrees. So we know that that's a 90-degree angle by putting that little square there. Okay. So if we know this is 90, that should be an arrow. I have to refresh my memory on how to write down this. So this is 90 degrees. This is 31 degrees. We want to know this one, but this one is defined using a variable. Okay, so I actually want you to contemplate that because there's a couple different routes, and there's going to be a common theme in this whole module. There's going to be many different routes we could take to solve some of these, and it's going to be whatever you're going to see first. So think on that for a second and see if you could set something up that would allow us to figure this out. Nothing crazy hard, but 3 weeks break. Let's see if we can shake the cobwebs loose a little bit here and come up with something that would allow us to figure out what X is going to be. Okay. Probably 2 or 3 different ways we could do this. Okay, I see 2 of the ways, so that's good. So, all right. Tomas. What did you set up, Tomas?
I put it 90 plus 31 plus x equals 180.
Okay, so I like a lot of that. So what he did is he understood that this angle here, which he put as 90, this angle here, which is 31, and then this angle here, when we add all of those up, don't those have to equal 180 degrees? Okay, so he basically took all 3 angles and added them up. The only thing I'm going to differ with is this angle right here. We don't want to use just a simple little x because what they're telling you that that angle is this expression right here. So that is what we want to put in for that third angle. So all he's done is he took that 90-degree angle, so this angle. He took the 31-degree angle, that angle, and then he took this final angle here, and he knew all 3 of those need to add up to be 180 degrees. And what he set up is just a simple little equation now. Okay, so did a bunch of these over the last year and a half. We want to simplify this side, so you're going to do 90 and 31. -1, if we combine all of those like terms, so you may need a calculator as we're doing all of these, a lot of computations with this. That's what, 120? And then we still have 3x equals 180. All right, so I did 90 plus 31, that's 121. Subtract the 1, that's 120. You still have the 3x, set that equal to 180. And then from here, I think most of us are good. You're going to subtract that 120 over 3x is going to equal a 60. All right, divide by that 3, and then x is going to equal 20. Now, answer the questions as well. So this is going to be a common theme. And as I look at it, I noticed on mine it wasn't formatted particularly well. And even on yours, the way I wrote it, so I'll apologize here. These directions kind of fed into the next line. This should say solve for x. You see that on your paper. But it's not just solving for x. I also want you to find the missing angle. So if x is a 20, we then want to figure out what does this angle here need to equal. There's a couple different routes, but if I now know that x is a 20, can't I just take 20, plug that in for x? 3 times 20 would have been 60. And then subtract that 1, and then we would know that's a 59-degree angle. All right. Now, that's one way we can do this. All right. We all got that written down. Can I erase this now? All right. So now I'm going to magically erase all of this, and I'm going to ask Armando, what equation did you set up, Armando?
59 equals 3x minus 1.
Okay, so what he did is he took this 3x minus 1 angle, and he right away set that equal to 59 degrees. Where did this 59 degrees come from?
90 plus 31, and then it was 180 minus 120, 121.
Good. So he knew all of these angles have to be 180. So what he did is he subtracted these guys away. So that's 121. And then what he knew is, doesn't this angle here then have to be 59 degrees? So he took this little expression that identifies this angle. He knew that had to be a 59-degree angle. And he used this little equation to solve that. So if we now solve this, we better get 20 again. So if I now add 1, if we're going to solve it this way, you're going to get 3x equals 60. When we divide, won't we get that to equal 20 again? All right. So again, as we do these, there's a lot of different routes we could take to these. So it's going to be a lot of, in many ways, what you see, and then just picking your best option. Okay. So that's the first one. Pretty straightforward. We'll see a lot of this. All three angles in a triangle need to add up to be 180. All right. All right. Next one. A linear pair. So linear, we talked a lot about this with linear equations, but you're going to see the word line right there. So a linear pair is a pair of angles, and we understand the idea of a pair is 2. So it is 2 angles who make a line. So if we look at the diagram that I have right here, see how we have this straight line right here? This line is created by 2 angles. The angle 4, oops, let me erase that one. So this angle and the angle 5. So those are our linear pair. Adjacent means they're right next to each other. So they're 2 angles that are right next to each other. They share a vertex and they form a straight angle. That was one of the words from Friday. All right. A straight angle is basically a line. Those have to add up to be 180 degrees. Okay. So hopefully you watched that on Friday. If not, that's one of the things that we talked about. Whenever we have a straight line, so from here to here, this is a straight line. These 2 angles must add up to be 180 degrees. So I'm going to write this just to kind of show it. This is angle 4 plus angle 5. Since they are a linear pair, those have to add up to be 180 degrees. All right, that's what that is in terms of a little equation. All right. Okay, also pretty nice. You'll see that, pretty simple. Next thing, exterior angle of a triangle. So if we have a triangle, we just talked about interior angles. There's always 3 interior angles. So this angle, and this angle. Notice how they're all inside of the triangle. So those are interior angles. So if I ask you for your exterior angle, it's got to be outside of the triangle. So this angle right here, angle 3, is not inside of the triangle. And that's why it's called an exterior. Just understand the idea of the definition of exterior. That's an angle outside of that triangle. Okay. That's an exterior angle. The remote interior angles are the angles that do not share a vertex with the exterior angle. So if this is our exterior angle, the remote interior angles are basically the interior angles that are opposite of that. So if this is our exterior angle, this guy here and this guy here, these are your remote interior angles because they're not adjacent to the exterior angle. All right, so again, a lot of little definitions here. We want to kind of stay on top of it. Last one for today, I think this is the last one. Yeah, on the bottom, and then we'll do some problems on the next paper or next page. There's a formula for this then. The exterior angle theorem, and that says the measure of the exterior angle of a triangle. So in this case, this is angle number 1. Notice how this is outside of the triangle. All right. So what that means is the measure of angle 1 would have to equal we keep reading here, is equal to the sum of the measures of the remote interior angles. Those are the inside angles that are opposite of that. So this angle right here has a degree measure of 40. This angle here has a degree measure of 30. We are adding those guys together. So that would have to just be 40 degrees plus 30 degrees. That must be a 70-degree angle. All right. Now, let's put that full circle with the stuff that we did before it, because doesn't this form a straight line right here? So we talked about a linear pair. If this is 70, what would this angle right here have to be, Armando? Yeah, because that has to add up to be 180, right? So this would have had to have been a 110-degree angle. Or don't all three of these interior angles, so doesn't 40, 30, and 110, don't those have to add up to be 180 as well? Okay, so we're kind of checking all of those boxes there, kind of putting all that stuff together. All right. Number 4. Similar. Here is our remote exterior angle. That angle, the 113, must equal the sum of the two remote interior angles. So it must equal the sum of 70 and 2. So again, a couple different routes you could take here. You might be able to do it in your head, but if we set up an equation, we're going to say that that has to equal the 70 plus that measure of angle 2. All right, if we're going to solve that, then we can go ahead, subtract that 70 over, and we get 43, not 63. 43 is equal, 43 degrees has to be the measure of angle 2. All right. All right, go to the next page. And now I like this. This is probably my favorite chapter, by the way, because it makes you think a little bit. It's kind of like little puzzles, forms some good thinking habits here. Answer number 5. Let's see what we think here. We got really 3 triangles. We have the big triangle, and then we have 2 triangles inside. And now kind of think through all the stuff that we just talked about on the previous page and see if we can come up with angle X, angle Y, and angle Z. Yeah, and you may need a calculator too for some of these. Good start. All right, give me about 30 more seconds here. A lot of us are getting X, and then if you get X, how does that allow us to get Y and possibly Z? All right. Alec. What did you do first, Alec?
First, I found X.
And how'd you do that?
I added 39 and 65 together, and I subtracted it from 180.
Good. So he looked at this triangle right here. So if we just took this individual triangle here, the inside of those angles have to be 180. So if all three of these have to add up to be 180, can you say that one more time? How did you do that? Did you do the equation or just subtract?
I subtracted it.
Okay, so he understood that within that yellow triangle right now, those all have to add up to be 180 degrees. Have to. Any triangle, the inside angles are always 180. So if we're only missing this angle right here, he then understood if they start with 180, let's get rid of the 39 degrees that I know and the 65 degree angle that I know. Whatever remains of that 180 after I subtract these two away would have to be this angle right here. What'd you get that to be, Alec?
76.
Good. That then gives us 76 degrees. All right. So we would want to say the measure of angle X. And when we identify a measure, we do want to put that little M in there. The measure, and this is our angle. We talked about that in the video from Friday. That's our angle notation. Kind of looks like an inequality. Just try to make this horizontal flat. That has to be 76 degrees. All right. So then from that, we over here, write this as a 76 degree angle. All right. So that was just using the inside of a triangle has to be 180 degrees. I saw a number of people do it. I don't remember off the top of my head. Anybody get Y then? How can we then go over and get Y? Asad.
Subtract 21 from 180. I guess this split which equals 150 now split it to Y.
So if these were the same, if we knew for a fact that the measure of angle Y was equal to the measure of angle Z, and we will eventually do problems like that, then yes, he took 180, subtracted 21 from it, and then he divided that evenly between those two. Okay. However, so we haven't talked too much about it. If I were to look at this angle here, and again, I think you've done this in the past. Do you guys remember words like right angles, acute angles, obtuse angles? Are those all familiar to us? All right, if we look at angle Z right here, let's actually test that thought then. Is that a right angle, an acute angle, or an obtuse angle? An acute, because it's what?
Less than 90%.
Perfect. So now let's look at angle Y. What do you think about angle Y right here? Acute, also obtuse. So can they possibly be the same if one is less than 90 and one is greater than 90? Okay, so good. So kind of work that out to know that we wouldn't be able to do that. Although we will eventually if we know those are equal to each other, and that's coming. In a matter of a week or two, we'll certainly deal with some triangles that are like that. All right, anybody else for Y? How could we get that Y? Monica. Okay, and why did you do that, Monica? Good. So on the front page, remember we talked about a straight line? Doesn't a straight line always have a degree measure of 180 degrees? So if this whole thing from here to here, this is what we called, so just kind of refresh our memory, see where we're getting this from. That's a linear pair. It's two adjacent angles that make a straight line. They have to add up to be 180. So if that's a linear pair, if this is 76, that's why Monica said she also took 180 because she knows 76 and Y better add up to be 180. So let's subtract away the 76. And how many angles or degrees remain there, Monica? Good. That had to be a 104 degree angle. So the measure of angle Y is a 104 degree angle. Let me circle these so we know these are our answers. All right, so then now we know this is 104. And again, you're going to see this in all kinds of different ways. So this one, once we know that angle, let's look at the triangle right here. Don't we know this angle is 21? This angle is a 104. All three of those have to add up to be 180. What do you find that to be, Asad? I see you plugging that in. Yes, we all get that. Appears to be 45. So, because now the blue triangle needs to be 180, so subtract away the 104, subtract away the 21. That needs to leave you with angle Z. So the measure of angle Z is then not 100. Was it 45? Is it 125? It's 55. Yeah, 55. All right, so 55 degrees. Okay, that's kind of why I like these. They're nice, kind of just little puzzles. You got to be sequential in your thought process. Good stuff. All right, number 6. What this is dealing with is this idea. This is what we call an exterior angle. It's outside of our triangle. And then these are your remote interior angles, the angles that are opposite of that angle. So if we go back up to our little theorem from the previous page, so know where we're getting this from. Your exterior angle is the sum of the remote interior angles. So we want to add the two angles on the inside, and they have to equal the degree measure of that outside angle. So if we come back over to number 6, this angle right here, the 4x plus 8, has to equal the sum of the two remote interior angles. Sum means you're going to add, so we're going to be adding this angle here, 2x plus 3, and then this angle here, which is 51 degrees. So kind of a common theme with all of these, we kind of start you out here just thinking through with numbers only, and then we follow that up the same thought process, but then it's a little bit of algebra. We're going to have to solve for x, okay? So this is now your equation. You have 4x plus 8 equals, we have some like terms on the right-hand side, so we're going to combine those first. So 2x plus 54. Continue to solve. So in this case, I would subtract this 2x over. So we get 2x plus 8 equals 54. And then from here, I think we're all good. Subtract that 8 over. We get 46. Divide, we get x to be 23. And then again, answer the question here. When we get to a quiz, we get to a test, you're going to have some multiple choice, even if it's not multiple choice. Here I'm asking you for x, so that is true. I want you to solve for x, but I also want you to find the measure of each angle then. So a lot of these, then you're still going to have some extra work to then do. So x is 23, so that's certainly part of our answer. But what I now want you to do is tell me, what is the degree measure of this angle right here, right? That remote interior angle. The reason we're able to now do that is, didn't we just find x to be 23? So all we need to do is let this x be a 23. And whatever this evaluates when this x is a 23, then we know that's the measure of that angle. Okay? Let me try to create some space here. So this would become 2 times 23 plus 3. That's 46 and 3. So this is a 49 degree angle right here. And then the last one, if I wanted you to find this blue angle where we had the x, again, same process. We now know that that x is a 23. So you're going to plug that in. Is that 90? Is that 100? Jada, did you just plug that in? Was that 100? I think it is. 92 and 8. Okay. Is it? Okay. Even I'm a little rusty too, and I'm not trusting my mental math there. So then that would be a 100 degree angle. All right. Okay. I will stop boring you there on the first day back. Bring this tomorrow. We will then kind of pick up. There's a new little one that we'll jump into tomorrow, and then there'll be some more problems. And I won't give you homework on your first night, but we'll finish this off tomorrow. Give you a little homework tomorrow. But yeah, good to see you all. Welcome back. How's your break, Stephen? Doing anything fun?